At 500 degrees Celsius, most things burn. Skin blisters instantly. Wood ignites. Metal glows red. But on the summit of Ol Doinyo Lengai, you can stand close enough to touch molten rock flowing from the Earth's core and survive. This is lava that moves like water. Lava that erupts black and turns white within hours. Lava so chemically impossible that when scientists first discovered it, their colleagues refused to believe the reports. It is the only volcano of its kind on Earth. The only one erupting liquid salt instead of molten stone. The only one that can shift, without warning, from gentle streams you could photograph at arm's length to explosive fury that hurls car-sized boulders thousands of feet into the air. In 2007, climbers stood at its crater taking pictures. Minutes later, they were running for their lives as the mountain tore itself apart beneath their feet. The Maasai have always known this mountain was sacred. They called it Ol Doinyo Lengai, the mountain of God, and kept their distance during the times when it spoke. Science has now confirmed what reverence always understood. This is a place where the normal rules of volcanism do not apply. Where the earth reveals chemistry that should not exist in the modern world. Where beauty and violence trade places so quickly that the line between wonder and disaster disappears. This is the story of the strangest volcano on Earth and why it erupts alone. There are places on Earth where the ground itself seems to remember ancient conversations between fire and stone. In northern Tanzania, where the Great Rift Valley tears the continent apart with geological patience, stands a mountain the Maasai people have always known by a name both beautiful and terrifying, Ol Doinyo Lengai. The Mountain of God. For centuries, the Maasai have walked these plains with their cattle, their lives measured not by clocks, but by seasons, by rains, by the rhythms of the earth beneath their feet. And always, rising 2,962 meters into the African sky, Ol Doinyo Lengai has watched over them. But this is no ordinary mountain. While most volcanoes wear their danger in shades of black and gray, Ol Doinyo Lengai presents the world with something stranger, a summit painted white and black, as if the mountain itself cannot decide between peace and fury. The Maasai understood what geologists would take decades to confirm. This mountain is alive. Not in the metaphorical sense we use for forests or rivers, but genuinely, measurably alive breathing. Changing, occasionally speaking in tongues of fire. On nights when the mountain grew restless, when strange lights flickered at its summit and the ground hummed with subterranean energy, the elders would gather. They knew these signs. Their grandfathers had known them. Their grandfathers' grandfathers had known them. The mountain of God was praying. What the Maasai called prayer, science would later call something else. The rarest form of volcanic activity on Earth. But in 1960, when a young geologist named J. Barry Dawson first climbed to the summit and peered into the crater, he discovered something that would rewrite our understanding of how volcanoes behave. Something so unusual, so contrary to everything volcanology had taught, that his colleagues initially refused to believe his reports. Ol Doinyo Lengai wasn't erupting molten rock. It was erupting liquid salt. And with that discovery, a mountain that had been sacred for millennia became scientifically sacred as well, the only active carbonatite volcano in the world, a geological miracle hidden in plain sight for thousands of years. To understand Ol Doinyo Lengai, one must first understand the wound from which it was born. The Great Rift Valley is not merely a geological feature. It is a work in progress, a tearing, a splitting, a continental divorce playing out over millions of years at a pace so slow that entire human civilizations rise and fall between movements. Here, the African continent is quite literally pulling itself apart. Tectonic forces deep beneath the surface are stretching the land, creating a scar that runs from the Mozambique Channel in the south to the Red Sea in the north. In geological terms, Africa is becoming two continents. The process is patient, relentless. The rift widens by mere millimeters, each year roughly the same rate at which human fingernails grow. But given enough time, millimeters become kilometers. Given enough time, valleys become oceans. And along this great wound in the Earth's skin, volcanoes rise. They are not random, they are symptoms. Each volcano marks a place where the tearing of the continent has opened pathways for molten rock to rise from the mantle below. They are, in essence, pressure valves for a continent under stress. But while Kilimanjaro sleeps under its eternal snows, and Meru dreams of eruptions long past, Ol Doinyo Lengai remains awake, alert, active. The mountain sits at a geological crossroads. Here, three tectonic forces converge. the African plate pulling westward, the Somali plate drifting east, and between them, the young Arabian plate pushing northward. The result is a zone of extraordinary geological violence, hidden beneath a landscape of deceptive tranquility. For millions of years, this process has continued. The rift has deepened. The volcanoes have grown. And deep beneath Ol Doinyo Lengai, something remarkable has been happening. While most volcanoes draw their fury from basalt, the common black rock that forms ocean floors and continental foundations, Ol Doinyo Lengai taps into something far stranger. Its magma chamber contains carbonatite, a molten cocktail of sodium, potassium, and carbonate minerals. This is lava that erupts cold by volcanic standards. Lava that flows like water. Lava that, when exposed to air and rain, transforms from glossy black to brilliant white within hours. It is this transformation, this alchemical change from darkness to light, that gives the mountain its distinctive appearance. The white you see from the plains below is not snow. It is not ash, it is yesterday's fury, weathered into innocence. The Maasai were right to call it the Mountain of God, in a valley shaped by continental forces, powered by the slow tearing of Africa itself. Ol Doinyo Lengai stands as something unique, a volcano unlike any other on Earth, and it was only just beginning to reveal its secrets. Before we continue this story, subscribe to the channel. Your support helps us tell the true stories of Earth's most powerful volcanoes. For most of human history, Ol Doinyo Lengai kept its secrets well. The Maasai knew the mountain was different. They had witnessed its eruptions, seen the strange flows that move like water in moonlight, watched the summit change colors with the seasons. But they had no reason to question why. The mountain simply was as permanent and mysterious as the stars themselves. It was not until the mid-20th century that Western science turned its attention to this remote corner of Tanzania. And when it did, it stumbled upon something that would challenge everything volcanologists thought they understood. In 1960, a British geologist named J. Barry Dawson made the arduous climb to Ol Doinyo Lengai's summit. He was not the first European to reach the crater. German explorers had documented the mountain decades earlier, but Dawson was the first to truly see what he was looking at. What he found defied explanation. The lava flows were wrong. Everything about them was wrong. They were black, yes, but with a glossy, almost metallic sheen that no basalt possessed. They were thin, spreading like spilled paint across the crater floor. And most puzzling of all, they were cold, barely hot enough to glow in daylight. Dawson collected samples. He took photographs, he made meticulous notes. And when he returned to his laboratory in England and began analyzing what he had brought back, he realized he was holding something that shouldn't exist in an active volcano. The rock was carbonatite. Now, carbonatite itself was not unknown to geology. Ancient carbonatite formations had been found in several places around the world, remnants of volcanic activity from hundreds of millions of years ago. But those were fossils, geological artifacts from a time when the Earth's interior chemistry was different. No one had ever found carbonatite actively erupting. The scientific consensus held that it was impossible, that whatever processes had created ancient carbonatites no longer occurred on modern Earth. Ol Doinyo Lengai proved them wrong. Dawson's findings were met with skepticism. Some colleagues suggested he had made an identification error. Others proposed that the carbonatite might be a secondary formation, created by unusual weathering rather than true volcanic activity. A few simply didn't believe him. But Dawson was certain. And as more researchers made the journey to northern Tanzania, the evidence became undeniable. Ol Doinyo Lengai was erupting molten sodium carbonate, essentially liquid washing soda mixed with calcium and potassium, at temperatures around 500 degrees Celsius. To put that in perspective, typical basaltic lava erupts at temperatures exceeding 1200 degrees. Ol Doinyo Lengai's lava was barely hot enough to glow. You could stand within meters of an active flow and feel only moderate heat. In theory, if you were foolish enough to try, you could touch it briefly without immediately suffering third-degree burns. This had profound implications. It meant that carbonatite volcanism wasn't extinct after all. It meant that somewhere deep beneath the East African Rift, unusual chemical conditions were creating magmas that the modern geological world had assumed were impossible. It meant that our planet still had the capacity to surprise us, even in processes we thought we fully understood. But perhaps more importantly, it raised a question that haunts volcanologists to this day. If Ol Doinyo Lengai is the only active carbonatite volcano we know of, Does that mean it's truly unique? Or does it mean we simply haven't been looking carefully enough? The discovery transformed Ol Doinyo Lengai from a local curiosity into a site of international scientific importance. Researchers began making regular pilgrimages to the mountain. Monitoring equipment was installed, papers were published. The volcano that the Maasai had revered for centuries was now being revered by science as well, for entirely different reasons. Yet, for all the attention it received, the mountain remained fundamentally mysterious. Scientists could describe what it did. They could measure its eruptions, analyze its chemistry, map its lava flows with increasing precision. But understanding why it behaved this way, why this particular volcano, in this particular place, produced this particular type of magma, that remained elusive. The Mountain of God had allowed humanity a glimpse into its nature, but only a glimpse. And, as researchers would soon discover, Ol Doinyo Lengai had far more dramatic revelations waiting. The gentle, almost approachable eruptions that Dawson had witnessed were not the mountain's only mood. Sometimes the Mountain of God whispered, and sometimes it screamed. Volcanoes, like people, have temperaments. Some are predictable. They follow patterns, give warnings, behave according to established rhythms. Others are capricious, changing their behavior without notice, defying the predictions of even the most experienced observers. Ol Doinyo Lengai has both personalities, and learning to distinguish between them has proven to be a matter of life and death. For most of its recorded history, the mountain has been what volcanologists call effusive. This is the gentle face of volcanism, the slow oozing of lava from vents and fissures, the gradual building of new rock layer by layer. It is volcanism you can approach, study, even film from relatively close range. The carbonatite lava flows almost peacefully. It bubbles from the crater floor like water from a spring. It spreads in thin sheets, rarely more than a few centimeters thick, creating a landscape that looks more like melted wax than molten rock. At night, these flows glow a dull red, providing just enough light to navigate by a photographer's dream, a geologist's playground. Climbers who reached the summit during these effusive periods described an otherworldly scene. The crater floor constantly reshaped itself. Fresh black lava would emerge, flow for a few meters, then begin its gradual transformation to white as moisture and carbon dioxide from the air reacted with the sodium carbonate. Within days, the glossy black would fade to gray. Within weeks, brilliant white. It was beautiful, accessible, almost safe. But almost is a dangerous word when dealing with volcanoes. Because Ol Doinyo Lengai has another face, one that appears without warning, transforms the mountain from laboratory into weapon, and has claimed lives with brutal efficiency. The scientific term is explosive eruption, but that clinical phrase fails to capture the violence of what occurs when Ol Doinyo Lengai shifts moods. The first well-documented explosive event occurred in 1966, just 6 years after Dawson's initial discovery. Suddenly, without the warning signs that typically precede major volcanic events, the mountain began hurling ash and rock thousands of meters into the air. The gentle, effusive activity ceased. In its place came Strombolian eruptions, violent gas-driven explosions that ejected incandescent fragments of lava in towering fountains. These explosions were different from the effusive flows in every way. They were loud, deafening booms that echoed across the Rift Valley. They were fast-producing pyroclastic material that traveled at speeds no human could outrun. And they were unpredictable, occurring in clusters. Sometimes dozens per hour, sometimes separated by days of deceptive calm. What causes this shift? Why does a volcano that spends decades gently oozing carbonatite suddenly begin tearing itself apart with explosive force? The answer lies in gas. All magma contains dissolved gases, primarily water vapor, carbon dioxide, and sulfur dioxide. As magma rises toward the surface, pressure decreases, and these gases begin to separate, much like bubbles forming in a bottle of soda when you remove the cap. In most volcanoes, this process is relatively straightforward. But Ol Doinyo Lengai's carbonatite magma has an unusual relationship with gas. The same chemistry that makes the lava erupt cool also makes it extraordinarily sensitive to changes in gas content. When gas content is low, the carbonatite flows smoothly, effusive, gentle. But when gas content rises, either because fresh magma from depth brings new volatile components, or because the magma chamber becomes oversaturated, the volcano's behavior changes completely. The carbonatite can no longer contain the expanding gases, pressure builds. And eventually, catastrophically, it releases. The result is an explosion that can hurl blocks of solidified lava the size of automobiles hundreds of meters through the air. Ash clouds rise into the stratosphere. The crater floor, so stable during effusive periods, becomes a killing field of falling debris and superheated gas. And here is the cruel reality. There is no reliable way to predict when these transitions will occur. Volcanologists have identified some patterns. Explosive periods tend to follow extended intervals of effusive activity, suggesting a buildup of pressure over time. Seismic activity sometimes increases in the days before an explosive phase begins. Gas emissions change composition slightly. But these are tendencies, not rules. Ol Doinyo Lengai has violated every pattern multiple times. It has exploded after brief quiet periods. It has remained calm despite seismic swarms that suggested imminent violence. It has shifted from explosive back to effusive without explanation. The mountain, it seems, follows its own logic, one that humanity has not yet learned to read. This unpredictability has consequences. In 2007 and 2008, during a particularly violent explosive phase, several climbing expeditions found themselves caught on the mountain when the eruptions began. Some were fortunate; they descended quickly enough to avoid serious injury. Others were not. Falling blocks struck climbers. Ash clouds caused respiratory distress. Burns from superheated fragments proved severe. The mountain of God had reminded everyone that reverence requires distance. Today, Ol Doinyo Lengai continues to alternate between its two personalities. Months of gentle effusive activity give way, without warning, to days or weeks of explosive fury. Then, just as suddenly, the violence ceases and the peaceful flows resume. It is a pattern without predictability, a rhythm without regularity. And it is precisely this unpredictability that makes Ol Doinyo Lengai both scientifically invaluable and persistently dangerous. There is a question that has troubled volcanologists since Barry Dawson first identified carbonatite flowing from Ol Doinyo Lengai's crater. Why here? Why only here? The Earth has over 1,500 active volcanoes. They dot every continent except Australia. They ring the Pacific in a chain of fire. They punctuate ocean floors with underwater mountains. They rise from rift valleys and subduction zones, from hotspots and spreading centers. And yet, of all these volcanoes, of all the countless vents through which our planet releases its internal heat, only one erupts carbonatite lava. Only Ol Doinyo Lengai. To understand why requires descending into the deep chemistry of the Earth's mantle, into processes that occurred dozens of kilometers beneath our feet, where pressure and temperature create conditions so extreme that rock behaves like putty and minerals transform into substances that cannot exist at the surface. The story begins with limestone. Millions of years ago, before the East African Rift began tearing the continent apart, this region lay beneath a shallow sea. Marine organisms, shellfish, coral, plankton lived, died, and settled to the bottom in countless trillions. Their calcium carbonate shells accumulated in thick layers. Over time, these layers compressed into limestone and other carbonate-rich rocks. Then the rifting began. As the continental plates pulled apart, these ancient seabed sediments were dragged downward into the mantle through a process called subduction. They descended into a realm of increasing heat and pressure, carrying their cargo of carbonate minerals into the deep earth. Under normal circumstances, carbonate minerals break down at high temperatures. The carbon dioxide they contain is released and escapes upward, either dissolving into magma or venting through volcanic gases. The calcium and other elements get incorporated into more stable mineral forms. But beneath Ol Doinyo Lengai, something different happened. The presence of sodium and potassium abundant in the rift's unique geology created conditions where carbonates could remain stable even at mantle temperatures. Instead of breaking down, they melted. And this carbonate-rich melt, being less dense than the surrounding mantle rock, began rising toward the surface. In the heart of Tanzania, standing sentinel over the Great Rift Valley, is a volcano unlike any other on Earth. This is Ol Doinyo Lengai, known to the Maasai people as the Mountain of God. While most volcanoes spew fiery, silicate-rich lava, Lengai erupts something truly extraordinary. A lava made of carbonates. This isn't the molten rock we imagine. It's a geological marvel that rewrites the rulebook on volcanism. So, what makes this volcano so special? The answer lies in its chemistry. Typical lava from volcanoes like those in Hawaii or Iceland is rich in silica, and erupts at scorching temperatures over 1,000 degrees Celsius. But Ol Doinyo Lengai's lava is a bizarre mixture of sodium and calcium carbonates, similar to washing soda. This unique composition allows it to melt at a remarkably low temperature, just around 500 to 600 degrees Celsius. That's about half the temperature of basaltic lava, making it the coolest lava on the planet. This low temperature has some incredible consequences. The lava is so cool that it doesn't glow bright red or orange during the day. Instead, it looks like a thick, black, oily mud bubbling up from the earth. Only at night can you see its faint, cherry red glow, a ghostly fire dancing on the crater floor. This strange appearance has puzzled and fascinated scientists for decades. How can a volcano produce such a substance? The leading theory suggests that its magma originates from a deep, unusual source within the Earth's mantle, one that is exceptionally rich in carbon dioxide and alkali elements. One of the most visually striking features of Ol Doinyo Lengai is its lava's high fluidity. Because it's so low in silica, the very element that makes most lava thick and viscous, Lengai's carbonatite lava flows with the consistency of water. It can race down the volcano's flanks at incredible speeds, creating delicate, intricate patterns that look more like spilled paint than a volcanic flow. These flows create a bizarre landscape of frozen black rivers and splash-like formations, unlike any other volcanic terrain on our world. It's a dynamic, ever-changing environment where the ground beneath your feet is constantly being reshaped. But the transformation doesn't stop there. As this black, carbonate-rich lava is exposed to the air and rain, a fascinating chemical reaction begins. The minerals within the lava, primarily nierite and gregarite, are unstable in our wet atmosphere. They rapidly absorb water, altering their chemical structure and turning from a deep black to a ghostly white. Within a matter of hours or days, the entire landscape can shift from a dark, foreboding terrain to a brilliant white expanse, looking more like a snow-covered peak than a volcano in equatorial Africa. This rapid weathering process means the mountain is in a constant state of flux, its appearance changing with every eruption and every rainstorm. For volcanologists, Ol Doinyo Lengai is more than just a curiosity. It's a living laboratory. It is the only active carbonatite volcano in the world, offering a priceless window into a type of volcanism that was likely more common in Earth's distant past. Scientists believe that carbonatite magmas may have played a significant role in the planet's early geological history. By studying Lengai, we can essentially look back in time, observing processes that have otherwise been lost to the geological record. It's a living fossil of a volcano, providing clues about the formation of rare mineral deposits and the deep carbon cycle that influences our planet's climate. Getting close to this natural wonder is no easy feat. It requires a grueling climb up steep, treacherous slopes of loose volcanic ash and rock. Yet, for a dedicated group of researchers, the risks are worth the reward. They camp on the crater rim, braving the elements to collect precious samples of fresh lava. Dressed in protective gear, they venture into the active crater, dodging splatters of molten carbonate to scoop up the black, syrupy liquid before it solidifies. These samples are rushed back to labs around the world for analysis, helping us piece together the puzzle of this strange volcano. The data they collect is invaluable. It helps us understand the magma's origin, its ascent through the Earth's crust, and the unique conditions that allow it to erupt. Each sample tells a story about the deep Earth, about the forces that shape our planet from the inside out. These scientists are modern-day explorers, charting a geological territory that is as alien as the surface of another planet. Their work isn't just about understanding one volcano. It's about expanding our fundamental knowledge of how planets work. The Maasai people have revered this mountain for centuries, believing it to be the sacred dwelling place of their god, Engai. They perform rituals and offer sacrifices here, seeking blessings of rain, cattle, and children. The volcano's rumblings and eruptions are seen as signs of Engai's mood, a direct line of communication between the heavens and the earth. This deep cultural connection adds another layer of significance to Ol Doinyo Lengai, reminding us that for the people who live in its shadow, it is not just a scientific wonder, but a powerful spiritual force that shapes their world and their beliefs. From its cool black lava that flows like water to its dramatic transformation into a white, powdery landscape, Ol Doinyo Lengai challenges our every assumption about what a volcano should be. It is a place of stark contrasts and profound mystery, where geology and mythology intertwine. It's a testament to the incredible diversity of our planet as natural processes and a reminder that there are still so many wonders left to discover right here on Earth. The Mountain of God continues to stir, a living, breathing giant that captivates scientists and inspires awe in all who witness its power. Thank you for joining us on this journey to one of the world's most unique geological sites. If you enjoyed this exploration, please subscribe, and hit the notification bell for more adventures into the amazing corners of our planet. See you next time. In the heart of Tanzania, standing alone in the Great Rift Valley, is a mountain unlike any other on Earth. It's not just a volcano. It's a geological marvel, a sacred site, and a creator of life in one of the world's most extreme environments. This is Ol Doinyo Lengai, the Mountain of God to the Maasai people, and its story is one of fire, ice-cold lava, and vibrant pink life. Imagine a volcano that spews lava not as the familiar fiery red rivers we see on TV, but as a dark runny liquid that looks more like motor oil. And here's the truly bizarre part. This lava erupts at temperatures that are incredibly cool for molten rock, sometimes only around 500 degrees Celsius. That's about half the temperature of typical basaltic lava. It's so cool that in the daylight, it barely glows. At night, it might give off a faint, dull red light, but during the day, it looks like black mud flowing down the mountainside. This is nature carbonatite lava, and Ol Doinyo Lengai is the only active volcano on the planet that produces it. This unique lava is made mostly of rare sodium and potassium carbonate minerals. When it erupts and hits the air, it reacts with moisture and begins to change almost immediately. Within hours, the fresh black lava turns white, creating a surreal landscape that looks like it's been dusted with snow. The mountain often appears streaked with white, not from ice, but from this bizarre, weathered lava. It's a chemical wonderland, a place where the rules of volcanology seem to be rewritten. For centuries, Ol Doinyo Lengai has been a relatively quiet giant, with its strange lava flows mostly contained within its crater. But in 2007, everything changed. The Mountain of God awoke with a fury that hadn't been seen in decades. It wasn't the gentle oozing of its unique lava. This was a violent, explosive eruption. A massive ash cloud billowed miles into the sky, visible from space. The eruption column reached heights of over 10 kilometers, raining ash down on the surrounding plains and villages. The sound was deafening, a continuous roar that echoed across the savanna. The Maasai, who live in its shadow, had to evacuate their homes as ash blanketed their pastures and contaminated their water sources. The eruption completely transformed the volcano's summit. The old crater floor collapsed, and a new, deep, steep-walled pit crater was blasted out. For climbers, who had once been able to walk right up to the small active hornitos or cones inside the crater, the mountain became a far more dangerous and unpredictable place. The summit was now a treacherous, unstable pit, a stark reminder of the raw power that had been unleashed. The 2007 eruption was a dramatic chapter in the volcano's life, showing that even this geological oddity could behave with the explosive violence of its more famous cousins. Climbing Ol Doinyo Lengai is a journey for the truly adventurous. It's not a technical climb requiring ropes and harnesses, but it is an incredibly demanding physical and mental challenge. The ascent almost always starts in the dead of night, around midnight. Why? Because the daytime heat in this part of Tanzania is simply too brutal for such a strenuous hike. You start under a blanket of stars with only the beam of your headlamp to light the path. The trail itself is steep, loose, and unforgiving. It's a relentless scramble up scree and ash slopes that can feel like taking 2 steps forward and 1 step back. The air gets thinner as you climb, and the effort required becomes immense. As you get higher, you traverse solidified lava flows. Their strange, crumbly textures a testament to the mountain's unique geology. The darkness adds a psychological element to the climb. You can't see how far you have to go, only the small patch of ground in front of you. Your goal is to reach the summit just as the sun begins to rise over the African plains. And if you make it, the reward is one of the most breathtaking views on the entire continent. You stand on the rim of the active crater, a stark alien landscape of white and gray ash. You can sometimes hear the rumble from deep within the earth and smell the sulfur in the air. As the sun breaks the horizon, it casts a golden light over the vast expanse of the Great Rift Valley. To the east, you can see the distant snow-capped peak of Mount Kilimanjaro. And to the north lies a sight that makes the entire grueling journey worthwhile, the shimmering crimson expanse of Lake Natron. But the mountain's influence extends far beyond its dramatic summit. Its true magic lies in how it shapes the world around it. The very same minerals that make up its unique lava are the lifeblood of the entire ecosystem. Over millennia, rain has washed these mineral-rich ashes down the slopes of Ol Doinyo Lengai and into the basin below, creating Lake Natron. Lake Natron is not your average lake. It is one of the most alkaline bodies of water in the world, a caustic saline soup that can be lethal to most forms of life. Its waters are so rich in sodium carbonate, the same chemical that flows from the volcano, that it can burn the skin and eyes of unadapted animals. The high evaporation rates in this hot, arid region concentrate these salts, making the lake's environment incredibly extreme. In fact, the alkalinity can be comparable to that of ammonia. This has a strange side effect. Animals that die in the lake are sometimes preserved through a process called calcification, turning them into eerie stone-like statues. Yet, in this seemingly inhospitable place, life doesn't just survive, it thrives. The extreme conditions that deter most creatures have created the perfect haven for a very specific type of organism. The lake is home to salt-loving microorganisms, a type of cyanobacteria, that bloom in the saline water. It is these bacteria that give Lake Natron its iconic and otherworldly colors. Depending on the salinity and time of year, the lake can transform into a swirling canvas of red, orange, and pink. It's a landscape that looks more like Mars than Earth, and it's this microscopic life that sets the stage for one of Africa's greatest wildlife spectacles. These cyanobacteria are the primary food source for a very special bird, the lesser flamingo. Lake Natron is the single most important breeding ground for lesser flamingos in the entire world. Up to 2.5 million of them flock here to breed, creating a sea of vibrant pink against the crimson water. Why here? The caustic nature of the lake that makes it so dangerous for other animals is precisely what makes it safe for the flamingos. The vast, shallow waters and the salt islands that form in the middle of the lake create a perfect, predator-free nesting site. Crocodiles, lions, and hyenas can't navigate the corrosive mudflats, so the flamingos can raise their chicks in peace. Their tough, leathery legs protect them from the alkaline water, and their specialized beaks are perfectly adapted to filter out the cyanobacteria they feed on. It is this bacteria, rich in pigments, that gives the flamingos their brilliant pink color. Without Ol Doinyo Lengai and its strange mineral gifts, there would be no Lake Natron as we know it, and this incredible flamingo spectacle simply wouldn't exist. So, Ol Doinyo Lengai is more than just a geological curiosity. It is the heart of this unique landscape. It's a mountain that spews black lava that turns into white powder. It's a sacred place that demands respect from all who approach it. It's a creator, its volcanic breath feeding a toxic lake that, in turn, becomes the cradle of life for millions of birds. It is a powerful and beautiful reminder of the intricate and often surprising connections that link geology, chemistry, and biology. The Mountain of God truly is the architect of this incredible corner of the world. Thanks for joining us on this journey to one of Earth's most unusual places. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell for more adventures into our amazing planet. See you next time. But there is a darker side to this relationship. Birds that die in the lake, whether from natural causes, exhaustion, or disorientation, do not decompose normally. The extreme alkalinity preserves their bodies, calcifying them in poses of eerie permanence. They become statues, monuments to the thin line between thriving and perishing in extreme environments. The same volcanic chemistry that enables life also threatens it. On land, the story is more complex. The immediate slopes of Ol Doinyo Lengai are nearly barren, too recent, too actively volcanic to support substantial vegetation. But further out, where older ash deposits have weathered into soil, life takes hold with surprising vigor. Acacia trees, those icons of the African savanna, grow in groves that mark the boundaries of ancient lava flows. Their deep roots tap into groundwater enriched by volcanic minerals. Grasses emerge after seasonal rains, turning the gray volcanic soil temporarily green. Elephants move through these areas, their massive feet leaving prints in ash that fell from eruptions centuries past. The Masash, too, are part of this volcanic ecosystem. Their cattle graze on plants nourished by volcanic soil. Their villages cluster at distances that balance access to resources against the mountain's unpredictable moods. They drink from springs that emerge where rainwater, filtered through layers of carbonatite, becomes mineralized but still potable. This is the paradox of volcanic landscapes. They destroy and they create. They threaten and they nourish. They are simultaneously among the most dangerous and most fertile places on Earth. Ol Doinyo Lengai embodies this paradox completely. Its eruptions can devastate, its ash can smother, its gases can poison. Yet its long-term influence has created a regional ecosystem that depends on volcanic input, an ecosystem adapted not merely to tolerate the volcano's presence, but to require it. Remove the volcano and Lake Natron's chemistry would gradually normalize. The extremophile algae would decline. The flamingo populations would disperse to other breeding grounds. The mineral-rich soils would slowly leach away, becoming ordinary savanna. The mountain of God shapes more than stone. It shapes the fundamental possibilities of life in its domain. It sets the chemical boundaries within which organisms must adapt or perish. It is, in the most literal sense, a creator not through intention, but through the inevitable consequences of its existence. And so the landscape endures, balanced between fire and water, between creation and destruction, between the mountain's ancient rhythms and the newer rhythms of life that have learned to dance to its beat. There is an irony in monitoring volcanoes. The more dangerous they are, the more essential observation becomes. And yet the danger itself makes observation difficult, expensive, and sometimes impossible. Ol Doinyo Lengai presents a particularly challenging case. Its remote location hours from the nearest substantial town, accessible only by rough tracks that become impassable during rainy season, makes permanent monitoring stations difficult to maintain. Its unpredictable shifts between effusive and explosive activity mean that equipment safe 1 month may be destroyed the next. And its unique chemistry means that monitoring protocols developed for typical basaltic volcanoes don't always apply. Yet the effort continues, driven by both scientific curiosity and practical necessity. The Masashi villages scattered around the mountain's base are not large, but they are permanent. Thousands of people live within the potential impact zone of a major eruption. More importantly, the region has become a destination for adventure tourism climbers seeking to stand at the crater's edge, photographers pursuing images of the world's strangest lava, researchers studying processes found nowhere else. Someone needs to watch, someone needs to warn. The primary monitoring falls to Tanzania's Geological Survey and international research institutions that maintain a rotating presence in the region. Their tools are the standard instruments of modern volcanology, adapted as best they can be to local conditions. Seismometers buried in the volcanic slopes detect the subtle earthquakes that accompany magma movement. Each tremor, some too small for human senses to register, is recorded, timed, analyzed for patterns. An increase in seismic activity often precedes changes in eruptive behavior, though at Ol Doinyo Lengai, the correlation is frustratingly imperfect. Gas monitoring stations sample the air near the summit, measuring the composition and volume of volcanic emissions. Increased sulfur dioxide or carbon dioxide can signal rising magma. Changes in gas ratios sometimes indicate whether the volcano is moving toward explosive or effusive activity. But again, the patterns are inconsistent. The mountain has fooled observers repeatedly. Satellite monitoring provides a broader view. Thermal cameras aboard orbiting platforms detect changes in the summit's temperature, the signature of fresh lava reaching the surface. Radar interferometry measures tiny deformations in the mountain's shape, indicating whether magma is inflating a chamber beneath the surface or draining away. These technologies have improved dramatically in recent decades. What once required dangerous summit expeditions can now be observed from space. What once could only be measured after an eruption can now be detected beforehand. And yet, Ol Doinyo Lengai remains fundamentally unpredictable. The 2007 explosive period arrived with minimal warning. Seismic activity had been elevated, yes, but not dramatically. Gas emissions had changed, but within ranges seen during previous quiet periods. The satellite data showed thermal anomalies, but similar anomalies had appeared dozens of times without leading to major explosions. Then the mountain erupted, violently and repeatedly, catching researchers and climbers by surprise. This unpredictability stems partly from the carbonatite itself. The magma's unusual chemistry means it behaves differently than the basalts that monitoring systems were designed to observe. Pressure changes that would trigger clear precursors in a typical volcano might produce only subtle signals at Ol Doinyo Lengai. The low viscosity means magma can ascend rapidly without generating the prolonged seismic swarms common at other volcanoes. But unpredictability also stems from incomplete understanding. Despite decades of study, scientists still cannot fully explain why the volcano shifts between eruptive styles. They can describe what happens, but not always why. They can measure the changes, but not always interpret them quickly enough to provide useful warnings. This creates a difficult situation for local authorities. How do you protect people from a volcano that can change behavior within hours? How do you balance the economic benefits of tourism against the safety risks? How do you communicate uncertainty without causing either complacency or panic? The current approach is cautious pragmatism. Access to the summit is officially restricted during explosive periods, though enforcement in such a remote area is challenging. Tour operators are required to check current activity levels before leading climbs. The Maasai communities have established informal warning networks when the mountain shows signs of restlessness. Word spreads quickly through traditional communication channels. It is not a perfect system. It cannot be when dealing with a volcano that refuses to follow rules. But it represents the best compromise between enabling scientific access, supporting local livelihoods, and minimizing risk. It acknowledges that complete safety is impossible, that some level of danger must be accepted by anyone who chooses to approach the mountain of God. And so the monitoring continues. Instruments record. Satellites observe. Researchers visit when conditions allow, collecting data that adds incrementally to our understanding. Each eruption teaches something new. Each quiet period raises new questions. The mountain remains patient. It has been erupting for hundreds of thousands of years. It will likely continue for hundreds of thousands more. Whether humanity learns to predict its moods or remains perpetually surprised is, from the volcano's perspective, entirely irrelevant. We watch because we must. The mountain endures because it can do nothing else. There are places on Earth that remind us of our proper scale, places where human ambition meets geological time and discovers itself to be fleeting, insignificant, and yet somehow precious precisely because of that insignificance. Ol Doinyo Lengai is such a place. For the Maasai, this has always been understood. The mountain is not something to be conquered or controlled. It is something to be respected, feared when necessary, honored always. Their relationship with Ol Doinyo Lengai spans centuries. Perhaps millennia, a relationship built not on understanding in the scientific sense, but on acceptance. The mountain is. It erupts, it quiets, it shapes the land. This is simply the nature of things. Western science arrived with different intentions. We came to measure, to analyze, to predict. We brought instruments and theories, we collected samples and published papers. We believed, as scientists often do, that sufficient study would eventually yield sufficient understanding. And we have learned much. We know now that Ol Doinyo Lengai is unique, the only active carbonatite volcano on Earth. We understand the chemical processes that create its strange lava. We can describe the tectonic forces that feed it, the gas dynamics that drive its explosive phases, the weathering reactions that transform black flows to white. But after decades of study, we must also acknowledge what we do not know. We cannot predict when the mountain will shift from gentle to violent. We cannot explain why this particular volcano, among thousands, produces this particular magma. We cannot say with certainty whether Ol Doinyo Lengai represents the last remnant of an ancient volcanic type or the first example of something new emerging from the evolving East African rift. The mountain keeps its deepest secrets still. Perhaps this is appropriate. Perhaps there should be places that resist complete understanding, phenomena that remain partially mysterious despite our best efforts. Perhaps the universe is under no obligation to make itself entirely comprehensible to creatures who have only recently learned to ask questions. What we can say with certainty is that Ol Doinyo Lengai matters scientifically, ecologically, culturally. Scientifically, it provides our only active window into carbonatite volcanism. Every eruption offers data unavailable anywhere else. Every sample collected from its flows contains information about deep Earth chemistry that we could not access otherwise. The mountain is a natural laboratory that cannot be replicated, experiment running continuously, offering results to anyone willing to make the journey and accept the risks. Ecologically, it shapes an entire regional system. Lake Natron's extremophile ecosystems, the mineral-rich soils that support savanna life, the unique chemical signatures in groundwater all trace back to volcanic influence. Remove the volcano and the landscape would fundamentally change. Species adapted to these conditions might not adapt to new ones. In the heart of Tanzania's Great Rift Valley, a lone peak pierces the sky, a perfect cone rising from the sun-scorched plains. This is Ol Doinyo Lengai, a name that resonates with ancient power. To the Maasai people, who have lived in its shadow for centuries, this is not just a mountain. It is the mountain of God, the sacred home of their deity, Lengai. Imagine standing at its base, feeling the immense scale of this natural cathedral. The air is thin, the landscape vast and raw. For the Maasai, this is where heaven and earth meet. They believe Lengai resides at the summit, a benevolent yet powerful creator who bestows blessings and brings the rains that sustain their herds and their way of life. When the volcano rumbles, it is Lengai speaking. When it erupts, it is a sign of displeasure. The mountain is a living, breathing entity, a barometer of the spiritual world. Pilgrimages to Ol Doinyo Lengai are a profound tradition. Maasai elders and spiritual leaders, known as Labans, ascend its steep, treacherous slopes to communicate with Lengai. They perform rituals, make offerings, and pray for rain, fertility, and prosperity for their community. Barren women seek blessings to conceive, and elders seek wisdom and guidance. The journey itself is a test of faith and endurance, a physical act that mirrors a deep spiritual quest. Each step is a prayer, each breath an acknowledgement of their connection to the divine. But Ol Doinyo Lengai's significance isn't just spiritual. It's a geological marvel unlike any other volcano on Earth. While most volcanoes spew fiery, red-hot silicate lava, Ol Doinyo Lengai erupts a bizarre, cool black lava called carbonatite. This unique lava is rich in rare sodium and potassium carbonates. When it flows from the crater, it's as fluid as water and barely hotter than a cup of coffee, around 500 to 600 degrees Celsius. It's so cool, in fact, that it doesn't glow bright red in the daylight. Instead, it flows like a stream of black oil. Once exposed to the air, a magical transformation begins. The moisture in the atmosphere reacts with the minerals in the lava, turning it from black to a ghostly white in just a few hours. The entire summit looks as if it's been dusted with snow or ash, creating a surreal, otherworldly landscape. Geologists from around the world are fascinated by this process. Ol Doinyo Lengai is the only active volcano known to erupt this type of lava, making it a priceless natural laboratory for understanding planetary formation and the deep, mysterious workings of our own Earth. Climbing Ol Doinyo Lengai is an experience that will change you. The ascent is typically done at night to avoid the brutal daytime heat. You start your journey under a blanket of stars, the Milky Way so clear it feels like you could reach out and touch it. The path is steep and covered in loose scree and ash, making every step a challenge. It's a relentless, vertical climb demanding physical stamina and mental fortitude. You're guided only by the beam of your headlamp and the silhouettes of your Maasai guides, who move with an effortless grace that is truly humbling. As you climb higher, the world below shrinks into a tapestry of shadows. The silence is profound, broken only by the crunch of your boots and the whisper of the wind. You become acutely aware of your own heartbeat, your own breath. It's a meditative experience, a stripping away of distractions until all that's left is you, the mountain and the vast, silent cosmos. There's no room for ego here. The mountain demands respect and humility. Reaching the summit as the first light of dawn paints the horizon is a moment of pure, unadulterated awe. You stand on the rim of an active crater, peering down into the steaming, churning heart of the earth. The ground beneath your feet is a bizarre landscape of solidified white lava flows, hornidos, and smoking vents. It feels like you've landed on another planet. The view is simply breathtaking. To the east, the sun rises over the horizon, casting a golden glow on the vast Serengeti plains. You can see the shimmering waters of Lake Natron below, famous for its flamingo populations, and the distant shadows of other volcanoes along the Rift Valley. In that moment, standing on the mountain of God, you gain a new perspective. You feel incredibly small, a tiny, fleeting part of a history that spans millennia. The concerns and stresses of daily life seem trivial in the face of such ancient, raw power. The earth is not just a rock we live on. It is a dynamic living system, constantly creating and recreating itself. Ol Doinyo Lengai is a powerful reminder of that. It forces you to confront the immense forces that have shaped our world and continue to shape it today. The Maasai have understood this for generations. Their worldview is not one of conquering nature, but of living in harmony with it. The mountain is not something to be defeated. It is a sacred presence to be respected and revered. It provides for them, but it can also take away. This deep respect is something we can all learn from. In a world increasingly disconnected from the natural environment, Ol Doinyo Lengai offers a powerful lesson in humility and connection. The lava fields at the base of the mountain tell a story of their own. Here, you can find the Ngare Sierra footprints, a series of astonishingly well-preserved human footprints left in volcanic ash between 5,000 and 19,000 years ago. Walking among these ancient tracks is like stepping back in time. You can almost feel the presence of the people who walked this same path thousands of years ago, living their lives in the shadow of this very mountain. It's a tangible link to our shared human ancestry, a reminder that we are part of a long, continuous story. These ancestors likely looked up at Ol Doinyo Lengai with the same mix of fear and reverence that people feel today. The mountain was a central part of their world, a source of both danger and life-giving resources. It connected them to the earth and to the cosmos just as it connects us today. Visiting Ol Doinyo Lengai is more than just an adventurous trek. It is a journey into the heart of what it means to be human on this incredible planet. It's a chance to witness a geological wonder, to experience a rich and ancient culture, and to reflect on our own place in the grand scheme of things. It challenges your body, expands your mind, and touches your soul. The white peak of the Mountain of God is a beacon, calling us to look beyond our own small worlds and connect with something larger, more powerful and infinitely more ancient than ourselves. It reminds us that we are guests on this planet, and that we should walk with respect, wonder, and a deep sense of gratitude. Thanks for joining me on this journey to one of the most sacred and unique places on Earth. If you enjoyed this exploration, don't forget to like, subscribe, and hit that notification bell for more adventures into the heart of our amazing world.